Hello and welcome to week 3, day 1 of our online learning. So I decided that we're going to actually start chapter 8 for most of April and get through chapter 9 in May, since we are now working strictly from home. And so I figured we're going to start with 8.1 today, which surprisingly is actually a pretty difficult section. So it's pretty hard being in school and learning this, but now it's going to be a little bit more difficult, I think, trying to learn on your own. But the nice thing is that you have a video, so you can kind of go back and look at the problems again as we go through them. If you get stuck, you can just stop it and kind of rewind a little bit. So take your time and try to digest this. It's going to be a little longer video than what we've been doing. I'm trying to condense the sections just to only do like the important information and try to do things that I hopefully are not going to be too difficult. Just kind of get like one small piece of each section as we go through. So again, this is for week 3, day 1. We're going to start 8.1 called function composition. So first we're going to do a problem that's kind of like a review that hopefully you guys already know how to do, and then we'll start with the new stuff. So if you look at number 1 here, it says if f of x equals 7x minus 11, find f of 6. This should be something that you're very familiar with and you already know how to do. So we're going to try this. So what do you do in a situation like this is we take the number that's put in for inside f of 6, and it's normally x, so they replace the x with the 6, and that's what we're going to do with this entire equation here. Instead of writing f of x, we're going to write f of 6, so the 6 actually goes into the x, and it goes into the x on the other side. So for both x's, you put 6. So you should be familiar with this. So f of 6 equals 7 times 6 minus 11. And then you just evaluate it. So 7 times 6 is 42 minus 11. So that gives you 32. So as a final answer, you could say f of 6 is equal to 32. That should be nothing new. Should all be familiar with that from chapters ago, and even probably from Algebra 1. So now we're going to move on to something called composition of functions or composite functions. So this is actually when you kind of have the same kind of idea like f of 6, but it's when you have 2 or more functions that are combined, i.e. one function is inside the other. So what does that look like? Well, if you look down here as an example, you have f of g of x. That's how this is read, f of g of x. When you see the parentheses, it does not mean multiplication. It is just the word of. It's notation. So you can kind of see inside here you have g of x, and then outside here you have f of the whole thing. So it's f of g of x. That's how you read that. So we're going to see how you tackle something like this. When evaluating composition functions, you must start on the inside. So when we do evaluate these, we're going to start inside where the g of x is and work towards the outside. Very basic. We're going to start from the inside and work to the outside. You do not start with the f on the outside and work your way in. You start from the inside and work your way out. So let's try an example here. So they have to define at least 2 functions. So this says let f of x equals x plus 5 and g of x equals 2x squared. So we're going to evaluate this. We're actually going to get a number out. So how do we work with this? Working on from the inside, you start with g of 3. So we're going to evaluate what is g of 3. The outside part is just going to stay there. So this is how I would write it. I would write f of, now I'm going to look at the inside. G of 3 means you plug in 3 into the g function. So what's the g function? They want us to plug in 3 for the x's here. So let's plug in 3. So I'm going to plug in 3 on this side here. So the outside stays the same, f of, so we keep the 2 there, and we're going to plug in 3 for the x. So it's 2 times 3 squared. Hopefully that wasn't too difficult to understand. We're just putting the 3 into the g function. So 3 goes into the g function. You have to find it up here, put 3 here, and I just copy it down below. The f I have not used yet, so I just have that in parentheses. So we're going to evaluate the inside here. This is going to be f of, well, the way you evaluate this is you have to do exponents first. So it is 3 squared. So 3 squared is 9, and then 9 times 2, 18. So that's just evaluating the inside to get g of 3 to get 18. Now, since we worked on the inside, we're done with the inside part. Now we just have a number inside left. And so we already know how to do this. This is a lot like the first example. How do you find f of 18? Kind of the same we did up here. How do we find f of 6? We plugged in 6 for x. So let's try it down here. We're going to plug in 18 into the f function. So we're working our way to the outside. F function is up here. They want us to plug 18 in here. So the other side would say 18 plus 5. I'm plugging in 18 to the f function. You no longer have to write f. You no longer have to write g. This is just going to be one number. 18 plus 5, 23. And that's your answer. So what is f of g of 3? Is 23. These are all connected with equal signs here. Keep going. So hopefully it's not too confusing. They're able to evaluate these with these numbers. It gets a little bit more confusing when we try letters, but we'll do that in a little bit. So let's try another one. G of f of 3. So we're actually doing the exact same number, but we are just replacing the order of how we evaluate this. Now we're doing g of f, and over here we did f of g. So let's look at the inside again. The inside says f of 3. That means you take 3 and you plug it into the f function. The f function is up here. So it wants to plug in 3 here. You're going to keep the g on the outside the same for now. We're not messing with g. So it's going to be g of what? Plug in 3 to the f function. So it's going to be 3 plus 5. Simplify the inside, you get g of 8. All right, so the f is gone. Now we're going to use the g function. So 8 has to go into the g function. That's over here. G of x equals 2x squared. So 8 is going to go in for that x. You no longer have to write g anymore. It's just going to be 2 times 8 squared. Then we evaluate. 8 squared is 64. 64 times 2, 128. Hopefully it's not too bad. That's your final answer. If you're confused, we're going to do 1 or 2 more like this before we move on to something a little bit more difficult. Just go back and rewatch some of these on how I did it. Okay, let's go down to part C. f of negative 4. So they can also do the same function on itself twice. So you can plug in a number to f, you'll get something different, plug that into f again. So we're not actually going to use g of x this time. So we're going to plug in negative 4 into the f function. So the outside one stays the same, f of whatever we get when we plug in negative 4. Plugging in negative 4 here, go up to the f function, negative 4 up there, we get negative 4 plus 5. So that's going to be f of 1. Negative 4 plus 5 is 1. Then we just do it again, rinse and repeat. We're going to go right into the f function again, but now we're plugging in the number 1. So 1 goes into f of x here, over on the right-hand side. So it's 1 plus 5, or 6 is your final answer. All right, last one with the numbers. Then we're going to get into something a little different. So we have g of 1. Now we're using g twice, which is okay. We're allowed to do that. We're going to plug in 1 into the g function. So plug in 1 here. Now we're only using the g function this time. So it's going to be g of, we're evaluating the inside here now. 1 goes into this here. So it's going to be 2 times 1 squared. It's pretty easy to evaluate. 1 squared is 1. 1 times 2. So it's g of 2 now. So now we're going to plug in 2 into the g function. So just using the g function again. 2 goes into the g function, so it means 2 has to go into 2 on this side. So it's going to be 2 times 2 squared. make sure you do squared first. So it's 2 times, what's 2 squared? 4. Final answer, 8. Also, one thing to point out from back here in part A and B is that we did f of g of 3 and got the number 23. And then by switching the f and g around and still using the same number, you still got a completely different answer. So even though we used 3 both times, we still got a completely different answer. Okay. Part E. Find an expression for f of g of x. So this is going to be like the harder part of it all. If you understand how to use the numbers and plug that in, this is going to be a little bit harder. Because now we're actually finding an expression. We're not going to evaluate and get a number. All these say evaluate. Down here we're going to get an expression. So let's go ahead and walk through this one. F of g of x. We're still starting on the inside, but we don't have a number to plug in. So instead, we're going to go ahead and look up here what g of x is. And whatever is equal to, which is 2x squared, since that's what it's equal to, we're actually going to replace that for g of x inside here. So let's write it out. We have f of, what's g of x? That is actually 2x squared. Normally we would evaluate this, but we don't have a number to use. So we have to keep the x there. So usually people are okay with that. Students are fine with that part. The hard part is this next step. So how do we evaluate this? F of 2x squared. Well, this is telling you to take the 2x squared. Maybe use a different color. Does that work? Take that 2x squared, and we're going to plug it in to the f function. So find the f function again. That is x plus 5. So wherever you see an x, which would be right here, you're going to replace this x with 2x squared. I know it's kind of weird, but you're taking whatever is inside the parentheses and you're replacing it up here. So I'm going to remove this x that's up there and replace it with 2x squared. So my final answer as an expression will be 2x squared. And then what else does f have with it? A plus 5. So that would be an expression for f of g of x. Let's practice a couple more of these, and then that will be all for this video for day 1. Find an expression for g of f of x. So the same thing, but we're going to flip it around. G of f of x. So on the inside, you have f of x. So what is f of x actually? Go back up. Maybe just erase some of this here. F of x is x plus 5. So we're going to replace f of x that's down here with x plus 5. So it's going to be g of x plus 5. Okay, then the last part. So there's really only 2 steps to these problems, but they can be difficult to comprehend. We're going to take x plus 5, and we're going to look into the g function. So the g function is up here again. So it's 2x squared. Erase that. We're going to take the x plus 5 down here, and we're going to put that into the g function wherever you see an x. So you see the x that's inside here beside the 2 and the squared. We're going to remove that x, take it out, and replace it with a quantity x plus 5 that's down here. Let me show you what that looks like. So we're going to take x plus 5 and put it into this thing here up here. G of x equals 2x squared. So instead of writing 2x squared, you write it as 2 times the quantity x plus 5, and then that gets squared. So I would probably highly recommend pausing the video and trying to maybe like understand where this is coming from and going back and like maybe rewatching if you have to, because this is a step where a lot of students mess up and it's just hard to comprehend, I think. So again, we took the x plus 5 that was inside here and plugged that into the g function, which is 2x squared. I removed the x that was in there and replaced it with x plus 5. Now, you can simplify this a little further. You could actually square it and distribute the 2, all that stuff, but we're just practicing the method of doing composition of functions. We're going to try one more problem. So we have two new equations now. S of x is 1 over x squared, and f of x is equal to x squared minus 64. And we're only going to practice doing the expressions. So we're not going to be getting out a number like parts A through, what do we do, A, B, C, D. Yeah, these all came out to be numbers. So it's going to be a lot like E and F that we just tried. So find an expression for S of f of x. What do we start with? F of x. That's what's on the inside. So I'm going to take f of x and take it out. We're going to remove it, and we're going to put what it's equal to. So find f of x. This whole thing it's equal to is going to go inside here. So we'll rewrite it as S of x squared minus 64. Again, usually you're okay with that. The hard part is the second part. Then we're going to look at the S function. Here it is, S of x equals 1 over x squared. And we're going to take this entire quantity that's down here, x minus 64, and that's going to replace the x in the function. So you look over here, it's 1 over x squared. So you basically can write the same thing, 1 over x squared, but instead of writing x squared, we're going to write this whole quantity that's being squared. X squared minus 64, and that is also being squared. So look what I did there. I took the x squared that's inside here, x squared minus 64, and that replaced that x in here. Take that out and put it in there, and your final answer is here. 1 over the quantity x squared minus 64 squared. It's a little bit more difficult, throwing a fraction in there. So let's try the other way. Find an expression for f of s of x. So look at the inside, it's s of x. We're going to replace it with what it's equal to over here. Should probably erase some of the stuff now. Got stuff going all over the place. Yeah, but we try a different color too. Okay, so s of x is 1 over x squared. So I'm going to replace that and put it in here. So we have f of, what was s of x? It's 1 over x squared. All right, now we got rid of the s of x. Now we're going to use the f function. So let's look at the f function. It's x squared minus 64. So this whole thing here, the 1 over x squared, has to go into the f function wherever you see an x. So there it is, x squared here. We're going to remove that x, pretend it's not there, and instead write 1 over x squared. So how would we write that? We'll keep the parentheses because it has to be squared still. The 2's still up there. So it's 1 over x squared. That whole quantity is being squared, minus 64. And that would be your answer as an expression. You can go a little further if you want to. You don't have to do this part. You could square what's inside the parentheses. 1 squared is 1. The bottom would become x to the 4th minus 64. But you don't have to do that right now. We're not focusing on simplifying it after that. We're just focusing on getting the expression for these kind of problems. And to go back, we're practicing getting an answer as a number. So if it says evaluate, you have to get a number. All these ones that say evaluate, you have to get an answer out as a number. If it says find the expression, then you're going to actually find basically like an equation. It still has a variable in it. So see how you do. There's going to be some practice problems on this page. And if you have any questions, make sure you send me a message through an email or on Remind. And we'll see you Wednesday.